Hi, and welcome to today's SPE Live, Computer Vision Systems and Data Analytics. Our focus is on novel technologies as applied to a variety of issues within drilling operations. My name is Nils Kaageson-Loe, and it's my pleasure to be your host today. Today's theme is part of this year's SPE IADC International Drilling Conference and Exhibition to be held virtually from March the 8th through to March the 12th. Our guests are on the show will be participating at the conference and will be sharing some of their insights and knowledge with us today. The conference has some really excellent content and speakers, so check it out. And if you are new to SPE Live, you can check us out on social media, hashtag SPE Live, or find us on SPE.org. Our collection of past broadcasts are available to you for you to watch at your convenience. So go to our website, SPE.org, or search on social media, hashtag SPE Live, and check out all of our content. It's all for free. There's some great content from 2020 and also all the new content now from January and February. So please check that out. So joining us today to talk about this vast topic of computer vision systems and data analytics for drilling and well construction, we have a really great lineup of guests today. So joining us, we have Blaine Dow, Global Operations Manager, MPD, UPD at Schlumberger, and Session Chair at the SPE IADC International Drilling Conference. Blaine is a 23-year veteran at Schlumberger, where he has specialized in drilling technology, operations, and business development. Joining Blaine is also Crispin Chatar. He is drilling subject matter expert at Schlumberger's Software Technology Innovation Center. Crispin, another Schlumberger veteran, earlier drilling engineer, center manager for Russia land operations. Crispin has held various roles mixing domain expertise, management, and digital technologies within Schlumberger. Also on the guest list today, Pradeepkumar Ashok, Senior Research Scientist at the University of Texas at Austin. Pradeep specializes in drilling automation and robotics. He is also CTO and co-founder of Panelists Incorporated, a tech startup developing and deploying edge analytics on drilling rigs. And our final guest today, Erlend Viggen, postdoctoral researcher at the Norwegian University of Science and Technology in Trondheim. Erlend is a physicist specializing in acoustics. His main focus are physical acoustics and computational physics and machine learning. He currently serves as co-chair of the acoustics group of the Norwegian Physical Society. Blaine, Crispin, Pradeep, Erlend, welcome all to SPE Live. It's a real pleasure to have you all here today. Thank you for making the time.
Thank you.
Thanks very much. See you all. Just a quick reminder to our audience, fingers on buzzers and keyboards, a big topic, lots of things to ask and explore around computer vision and data analytics systems for drilling. So please share your questions and comments and engage with our experts. This is a great opportunity to talk to people about these technologies. So, as I said, computer vision systems and data analytics, a big hot topic. Now, you guys are all participating at the SPE IADC conference next month. Blaine, please kick us off by giving us some perspective on the session that you're chairing and the conference itself and how these fine gentlemen have been brought together in your session.
Sure, thanks, Nils. So I think if I look back in time to the first time I attended this particular drilling conference, it was 2005. And we have seen over the course of, since that period of time, a lot of evolution in topics that are relevant to the changes that we've witnessed in our industry in general. So that coupled with what the world is going through right now with the pandemic, we really thought this SPE Live event would be a good opportunity to pull out one particular category of work that was done by a group of fine people represented here today that kind of parks itself in the middle of technology being applied in not so obvious ways where we can have instant business value and it can be adapted very quickly. And I think the adapted very quickly is something that you're going to hear us talk a lot about today, just particularly because of the nature in in how the world in general, and certainly our industry, has had to adapt so quickly to this pandemic issue. So with that kind of foundation laid down, let me start off by having Crispin maybe give a little bit of overview about his paper, and then we'll go through the rest of the participants.
Sure, Blaine. So our paper is about using vision analytics to calculate or infer the state of the rig. So what we do is we try to use this information to do drilling analytics. It's quite important to have this information actually. And today we're actually calculating that stuff from sensors that are around the rig and trying to, infer these states. So what we decided to try is to use computer vision, so cameras on the rig floor, looking at the activities and estimating, what's going on the rig. Are we drilling? Are we sliding? And so on. And that's about it in a quick nutshell.
Very good. Pradeep?
Sure, yeah. Our paper relates to using images to figure out what's actually happening to the bit. Everybody knows that without or in the absence of downhole data, the drill bit is the best indicator of what happens downhole. What happens these days is once the bit comes out of the hole, the people at the rig and experts kind of look at the bit to kind of figure out what's actually happening and then take corrective actions for the next bit drop. Of course, the problem here is that there can be a lot of subjectivity. So what we attempted to do was use images captured with mobile phones to see if we can figure out the actual causes of failure of the bit, kind of a bit forensics through computer vision. And the paper shows that it is possible to a high degree of accuracy. And so happy to be presenting that at this conference.
Excellent. And Erlend, how about yourself?
Well, the background of our paper is well-integrated logging. So well-integrated logs, they're pretty complex, right? And they need to be interpreted. They're not like straightforward to determine from like what is actually down in the well. So people who do this interpretation see logs from usually acoustic tools, which is basically a collection of images and curves. Then they have to do this interpretation process on this complex and maybe ambiguous data under time pressure as well, which like Pradeep said, can lead to a bit of subjectivity in our case as well. So what we want to do is like help these people by giving them an automatic interpretation to start from. So use like the various log images and curves as input to computer vision machine learning techniques, quite similar to what the other guys here are using as well, which help us make initial analysis of the well log data.
Very good. Thank you.
Oh, you're muted, Nils.
There we go. Now I'm not muted. So, thank you. So between you all, you have quite different use cases and perspectives, particularly around computer vision systems and how they apply. So, there's obviously a common challenge to try sort of look at, you all face common challenges in sort of the data and how it's applied and analyzed. So with application of machine learning and AI to reduce error time and improve decision efficiency and accuracy, from your different perspectives, how much is achievable from data analytics and how much is limited by instrumentation or work processes? Blaine, I'll let you kick us all off on that.
Okay, so one thing that I find particularly compelling about our topic here today is, and I'll put it in context relationship to another body of work that the SPE and IADC have been working on for nearly a dozen years. If for those that do recall, DSATs, drilling systems automation, is a focus group that came together to look at how drilling automation can actually be brought to mainstream, and a whole bunch of hurdles that relate to it and a whole bunch of opportunity challenges. And it's been a fairly consistent effort that has gone through peaks and valleys of success and challenges over an extended period of time. What I find interesting about what we're talking about here today is you're talking about a discrete piece of technology application that would fit squarely inside of drilling systems automation, but the work scope is a little bit specific, and it allows us to actually to showcase some success that's related to drilling systems automation technology foundation blocks, I guess is the way I would call it. So rather than trying to make an automated drilling rig, I would consider that trying to boil the ocean. We're not doing that in this case. It's something a little bit more focused and possibly has an ability to be more achievable.
Yeah, and I kind of agree with that concept there. Instead of actually doing everything or trying to do everything, do bits and pieces of it, and that's kind of the core to what we did as well. If you look at what we tried to do, it was to use bit images to actually figure out what happened to the bit automatically, right? And from a technology standpoint, that's not difficult to achieve because everybody on the rig side has a mobile phone, and these days they take pretty accurate photos or pretty high resolution photos. And so, you also have machine learning algorithms like YOLO, etc., that are very easily implementable on Android and iPhones. So so we have the technology, and the work process or the workflow is also pretty straightforward because on the rig, you anyway take photos of the bits. So why not just create an app that allows you to process those bit images and provide instantaneous forensics on the bit? So it's just one piece of drilling automation, but all these pieces come together to actually improve the efficiency on the rig.
Yeah, I'd like to. I'll sort of agree with that as well. The thing that I've seen is, this isn't the only project that we're doing with vision analytics. We're also looking at other areas as well, and one of those areas is how do we transfer some of that work to the edge, right? So I see John Andrew had asked a very similar question to that. And one of the things that we've found is, limitations that we have today aren't necessarily in technology in our industry. It's just the move ahead to go ahead and start it being done. So in our case, we have these cameras that are on the rig. They're used for one thing or another, and we've decided to use this as a dual purpose. And we can use those cameras to replace the sensors to do estimations on what people are doing and so on. And what we find is, we're able to put all the little pieces together, as Blaine is saying, to kind of start on one end of the spectrum and end up at the other end, start joining them. So for example, we can use these cameras, for example, for safety, for looking at HSE and so on, right? So that's also important to consider.
I think going back to Nils's original question, like how much can we achieve with data analytics? I think one general problem here is that we are working with quite difficult problems where there aren't necessarily any ground truths to train on. For example, as Pradeep said, they have this kind of subjective interpretations of the status of the drill bit, and in our case, we have subjective interpretations of well logs. And yeah, I think that's a general kind of problem with these problems. Like you don't really have a good ground truth to base yourself on, and that's a challenge that needs to be dealt with.
I think that if you're having a self-driving car, for example, and you have these cameras that are telling you what's around you, it's quite a different problem to solve. So when you look at in our world, for example, let's say we wanted to put a camera down in the ground. What would we use to train it? Like, how would we know where we are? We can't identify trees and people standing at the side of the road. So it does become quite a difficult problem to solve.
Exactly.
Yeah, and
Yeah, if I may, guys, I just want to chip in here because we had a really good question from the audience already. So John Andrew Kalfayan on YouTube, his question, can you discuss the challenges in the industry with trying to implement machine vision at the edge? So it's really picking up from what Erlend just said and Crispin just said. So Pradeep, maybe I'll just hand it back to you. Can you sort of maybe begin to address that? I mean, it sort of builds into what you guys are doing with the cameras, right, and the drill bits.
Yeah, so I mean, with regards to, I think the question is with regards to machine vision. So of course the cameras, right, are using mobile phones to capture photos of drill bits. They're pretty straightforward. That's not a big challenge. But we are doing a project where basically we are just looking at the cuttings coming out of the shale shaker, right? So one of the issues that we generally face is essentially making sure that we have class 1 div 1 and those kind of issues. So of course, if we don't, if you're not, of course, there'll be some rigs where there would be privacy issues that would kind of need to be answered with regards to basically putting cameras. But the projects that we are doing, there's not a whole lot of challenge other than basically the requirement to be able to put the camera on the rig safely.
Yeah, if I can also comment, when we talk about challenges, I think it's interesting when we're talking about technology adoption, especially in the space of automation, where you're having a machine or a piece of technology or a camera in this case take over for what a human would have done in the past, or is proposing to be doing in the past. One thing that seems to be a resistance blocker that we need to get through as an industry is everybody is concerned about the false negative that comes through, or the technology actually failing. And they don't want to have a catastrophic event because you relied too heavily on that piece of technology. But interestingly, the whole thing, machine learning, people learn too. So we have made 125 years of mistakes drilling wells over that's more than a century. And it was okay for humans to go through that learning curve, but it seems there's this stigma to allow machines to go through that learning curve. We want to step in and prevent that from being our catastrophic downfall. So I think that's a human factor that we need to get over.
With respect to the edge particularly, I would say anyone today you can take a TPU and connect it to a Raspberry Pi and a webcam, and you can hook that up anywhere and run some models, right? One of the problems that we've been finding recently is some of the models that we develop for use and we run on the cloud, actually we need to optimize it to be able to be run on the edge. And so that's something that we're working on as well, taking the same models that we're running on cloud and transferring it to the edge to be able to run it on much lighter infrastructure.
I think going back to what Blaine said about having algorithms make decisions, well, we can look at what's going on in another field, which is something that my colleagues here at NTNU are working on, like machine learning for data analytics and medical ultrasound, where you have ultrasound heart images, and you try to kind of help doctors come up with good explanations of what's going on with the heart, right? So you're not actually trying to make the decision instead of the doctor. You're just trying to give the doctor decision support. And I think that in oil and gas as well, this will be like the natural way to start doing it. Like, you don't make the decisions for people, you give people better information on which to base their decisions.
If I may just interrupt here again, guys, because it's a really good conversation. So I'm picking up, you all mentioned something about ground truths, and also Blaine, you made a really good point about people's perception and even impatience for computer models making errors. You said that we, as humans, we made plenty of errors drilling wells, and now we're impatient for the computer models not to do so. So really on that piece there, I want to pick up a question earlier from Amir Mo, who was asking about wired pipe and how that kind of information can help improve our data analytics, particularly relative to drilling operations. It's actually an earlier question from Amir Mo on wired pipe. Let me just pick that one up here. Sorry, guys.
Yeah, I can.
Please, yeah, go ahead.
Yeah, I can kind of take a shot at that. So, basically, even for the project that we are working on, when we are trying to do forensics on the actual drill bit, we are looking into actually combining the image, the information that we get from the image with the real-time data, right? So information fusion or data fusion always provides you better certainty over what actually happened. So if you have wide pipe data, definitely you can actually improve the improve your interpretation of actually what happened.
One of the things that we're actually working on right now is merging the physics models with the machine learning. So quite a number of projects that we have going on. There's a map or a physical model of the world, but there are gaps in it. So we don't have all the data, and we're trying to fill those gaps with data analytics, right? So you get the best of both worlds, and that's been proven to be quite useful.
And I think that machine learning is particularly useful in cases where you don't actually have any kind of physical model or mathematical model to base yourself on. There's a bunch of problems like that where you just have human knowledge and human intuition and experience to make decisions from. And in some of those cases, machine learning can help where mathematical models and physical models are not able to help because of the way that the problem, like, it can be difficult to describe mathematically.
Yeah, and it's pretty interesting because Erlend's topic is kind of actually comparing them both, right? I mean, deep learning versus shallow learning, right? Where on one case we let the algorithms figure out the features for themselves, and in the other case you show the features, right? And so we had this kind of thing, I'll let Erlend kind of talk about his project in just a bit. I mean, we had this kind of issue in our case as well, where we had images of the drill bits, and we had to identify the cutters. So in this particular case, it was difficult for us to give it the features, right? So there we had to use a convolutional neural network to automatically identify the features as to what exactly is the cutter. Of course, Erlend can kind of talk about his experience with his research topic.
So if I can just maybe circle back to Amir Mo's point about wired drill pipe. I think that was quite a compelling question related to this topic, and I'll tell a little anecdote here. Maybe some audience members are familiar with Jeff Moss. He was one of ExxonMobil's technical experts. He's retired now, but he left us all kinds of legacy in the industry. And I remember years ago, he made a statement about wired drill pipe. He said, wired drill pipe is a great thing, but it's like the Autobahn. You can get on there and you can go as fast as you want, 100, 200 miles an hour, it doesn't matter. But it doesn't have an on-ramp or an off-ramp. And fundamentally what he was saying is that there's no way to get all of the necessary data onto that transmission highway, nor is there a method to get the data off the transmission highway and turn it into useful decisions that come in with the speed that the data is coming in. So I think in this context, data analytics and machine learning and visual interpretation of data, that's actually a huge tool to be able to supply the off-ramp for wired drill pipe. So I think applications like we're discussing here today is probably just starting to crack that nut open of ways to take advantage of some technology that may have been before its time. I think wired drill pipe fits squarely in one of those technologies that was before its time.
Yeah.
No, great point there, Blaine. So that kind of brings us on to, I guess, the next sort of question or talking point for you guys is really the question of data availability and the data divide between operators and service companies. You know, a lot of what you've been talking about now has been about how we can take data and apply it to solve particular problems, and even, you know, you've been talking about discrete advances in technologies. So my question then is really, do new data analytics and data vision technologies require new types of contracts and agreements between service companies and operators, and service companies and service companies? Do the existing methods of contracts and agreements sufficiently value data and allow new types of risk and reward agreements, or should we look at advancing how we share data between ourselves and the industry?
Yeah, it's a very good question, and you're right. It depends on the scenario. In some cases, of course, there would need to be new contracts, and in some cases not. A place where you don't need a new contract is basically maybe taking the photos of the drill bits using phones. But a place where you may need new contracts is essentially if you had a 3D drill bit scanner, which these days multiple companies are providing to the industry. There are concerns about the 3D scanner capturing so much information that proprietary bit design information is captured. So in those cases, we may need to actually think about new contracts that protects everybody involved, the one who provides the 3D scanner and the bit manufacturer.
Yeah, one of the things that I think you need to do first is you need to do some data classification and identify what sort of data should be, considered as providing a strategic advantage to different companies versus service companies versus operators. And once we do that, then we can decide which of those sets of data could be used without any compromising.
I just want to point to an example where releasing data has been done already, because I think a lot of oil companies have an interest in releasing data more publicly to spur innovation that they can then pick up from service companies and so forth. And actually, there was a big data set released in 2018 called Volvo Data Village. That's like several terabytes of subsurface data released by an oil company. So it goes to show that it is possible to actually achieve this, even with the kind of contract structures that we have today.
Yeah, and I think if I look back and Schlumberger is a data company. That's basically what we were founded around, is providing data to define what the reservoir asset is to operators. And if I look back in time, drilling data used to be cast-off data. It wasn't wasn't considered proprietary. It was considered used and consumed at the conclusion of the well, and maybe you might archive it and go back and look for drilling surprises that could come back and haunt you later on, to make sure that when you're drilling your next sequence of wells, you can prevent that event from happening. But as drilling automation has evolved, suddenly I think there's a value in having that data now that we can actually process it. And to Crispin's point, data classification, even the classes that you put it in are evolving because of this move in technology advance. So effectively what that circles around to is somebody's going to be able to capitalize on creating value with that data, but it costs a lot of time and effort to be able to put the research and development into that product evolution to turn it into something that they can monetize and get return on their investment. And that's been a tricky barrier. Drilling automation has gone through that and we continue to not have the clear answer on that moving forward too.
Thanks, Blaine. If I may, I just want to interrupt you. Another great question from the audience. S. McNeil, talking about, I guess, really definition of flat time. he's mentioning here fat timing, pipe handling, not being so the biggest problems with drill ships and that sort of thing. So Blaine and Crispin, the question to you guys really is our understanding of rig activity changing because now we have more instrumentation on board the rigs and we have a better idea of what's going on at any one time in any one place. Do you think that new understanding from that kind of visualization, is that going to change the way we manage contracts and services on the rig?
So in context of the question related to downtime on equipment, for example, if I can pivot and use a correlating example of what we term downhole drilling data, you're looking for dysfunctions during the drilling process and identifying that as either you intervene during the dysfunction or you prepare yourself for the consequences of upcoming failure. You plan a trip out of the well. For example, if the drill bit is showing some kind of a lateral vibration that you know is going to cause a termination of that run. I think the same kind of data processing analytics can apply to any equipment on a drill rig as well, because the machine itself is going to give you some identity of a dysfunction coming through continuous health monitoring, which is now becoming another significant movement in our industry as well. So I think in general, we're once the methodology of processing the data is derived, I think it has applications across different problems on the drilling sequence that we're trying to solve, whether it's surface or downhole, whether it's equipment or whether it's the subsurface rock that we're drilling.
Yeah.
The thing that I've realized is we don't know right now what are the different workloads that are going to evolve, or what are the insights that we can get from this data, right? I give you an example. Right now, we're training the models with data that we have that was there in the past, so data from sensors and so on. But now we can use that, for example, in the case of the rig state, we can use the information from the cameras to figure out things like when did I have a safety meeting and when did I make up my BHA and things that aren't typically captured by the sensors on the rig. And then we can use that to now build new data sets with new information that we can start to do things like compare plan versus actual, for example. And there's tons more where we haven't figured out yet just how powerful the data is or what insight we can get until we have that data and we start looking at it and starting to get that data labeled. So that's going to be key moving forward, to figure out what we want to do with the data.
Thanks, guys. So I just want to pick up one more audience question. So from Artura Ramilevich, I think how you say his name. So his question: do you have any concepts of? We're talking about geosteering and autonomous systems to analyze logging while drilling to make on-the-fly decisions and downlink to the BHA. So. Really picking up from what you just said there, Crispin, about gaining more access to more data to make more decisions, and maybe I'll let you, Crispin and Erlend, pick this one up to begin with, and then maybe Pradeep, you want to add in here in terms of this kind of on-the-fly decision making.
So I can tell you that many companies are working on a lot of different styles of automation, and they're coming at it from a lot of different angles. Well placement and geosteering is just one. But in the context of what we're talking about here, in terms of vision analytics, we have been looking at automatically looking at the data, the logs, for example, and making decisions. Now, what you do with that decision depends on how fast you can process the data, how fast you can get the insight, and how fast you can feed it back, close the loop to the control systems that that you may want to, whether it be the rig or the tool downhole, and so on. And that goes back to something that we had a question on earlier on about the edge. That's where edge processing may come in, because if you can do it on the edge, it makes it a lot easier.
I agree, and just to kind of add to that particular topic, right? There is an initiative going on in this industry called OSDU, or Open Subsurface Data Universe, and the goal with this is to actually enable multiple parties to share data or to have data flow for things like these, where geosteering, where you need to get seismic data and you need to get drilling data all combined together. Initiatives like these are what are going to actually propel it. There's already quite a bit of algorithms developed. We just need to ensure that the data flow needs to happen, and it's really good that the industry is actually moving towards in that direction.
So I just wanted to make one interesting point is we actually have some papers specifically on that topic that are going to be presented at our conference. So it's almost like that was a planted question to help encourage people to attend the conference. So I'm really happy that we heard that one. But it just goes to show how broad of a application this new method of applying data analytics has spread across. Just as I guess we're nearing a time to conclude here. So there's one other key topic that we wanted to kick out to you guys that are going to be presenting at the conference. It's in terms of technology adoption in our industry. I think everybody has an opinion on it, and all of you are at the forefront of developing technology. What's your feeling on its adoptability and adoptability in general?
Yeah, I can take a shot at that. I think this last 1 year, with the pandemic and all, there's been quite a bit of acceleration. And really, while at one time we were thinking that oil and gas would eventually kind of decline, and it would slowly kind of go down in terms of renewables. But geothermal is picking up, and it's going to be a major contributor to the portion of drilling. So overall effect would be that we will be drilling a lot more, and we need to drill a lot more efficiently. And all these new players who have come into the geothermal stream, they are actually developing and innovating at really great speed. So I think the next 3-4 years, you would see a lot of adoption of technologies because what happened in 2020 has kind of disrupted quite a bit of the usual process.
So I think like this computer vision stuff is really taking off in oil and gas right now. I think last year or the year before that, I was looking at the proceedings of a conference on well logging and seeing that that year there were like 10 papers on computer vision for well logging, and the last year there was just like 1 and hardly anything before that. So this is definitely something that is really taking off right now, what we're talking about now with computer vision taking off in oil and gas. I think that there's a lot of exciting things left to do, a lot of kind of low-hanging fruit where we can apply this kind of tool to come up with well, interesting things that can help the oil and gas companies and service companies to basically help them along in their job.
I think I have a unique position on this, right? Because basically my job right now is to go out and hunt for that technology and bring it to the industry, right? So I get to see from ground up, anywhere from the very small startup companies to the major players, and what they're doing and their technology that they're coming up with, sometimes 5-10 years ahead of anything that will be released. And what I can say for sure is we are just scratching the surface on vision analytics and what we can do. There are things that will just amaze us that are coming up in the future.
So Crispin, if you don't mind, can we flip that around? Because you've been an industry expert for some time, and another question back to everybody. What about technologies that were born in the oil and gas industry and have opportunity to export to other industries?
Yeah, definitely. And of course, given that I'm kind of, currently doing research both on drilling for oil and gas and geothermal, right? I can see that a lot of what we have already come, because oil and gas had scale for a long time. So our technology had kind of, improved quite a bit in terms of geothermal. So that's one place I'm seeing a lot of current capabilities being exported.
Yeah, we're seeing that not only in vision analytics, but in a lot of other technologies. Just think about what we do on a daily basis. We're taking a signal from miles down in the ground, and we're transmitting it up the hole to people anywhere on the globe that can control our drilling. That's pretty much like flying a spaceship, right? There's a lot of opportunity there to transfer some of the things that we do to other industries. And we have been actually, even with the vision analytics, right? You think about all the stuff that we're doing now with the bits, we can certainly look for ways to move that to other industries and do analytics like that.
Yeah, I totally agree. Here in Norway, we saw like a few years ago when there was like an oil price shock and people started being laid off from oil companies. A lot of those people just started new companies, basically using the experience and knowledge that they got from the oil industry to work on a new field. And yeah, I think that there's a lot of stuff from the oil industry that can be brought out into other applications like that.
Crispin, I really like what you just said there about, the parallels between oil and gas and the space industry. And it goes back to some of your earlier comments as a group, about the ground truths and sort of how we are drilling in a subsurface that we can't essentially directly touch. We have to measure, make decisions based on measurements. So really, really good conversation between you guys. I'm just wondering, so looking ahead to the conference next month, but also as we step forward again and build up activity within the industry, for all of you, what are you looking forward to in terms of the next big steps in data analytics, computer vision, drilling automation? What are you excited about? Let's start with you, Blaine.
Well, I'm excited, first of all, to participate in this conference as the very first ever virtual that we've done. I think this is quite a game changer, and we'll see how it goes. I think there's aspects that are going to be better doing it virtually, because you can participate in a lot more content than we've been able to do in the past. When we're there live, we can only select one of three things going on simultaneously. But in this case, you can comb over the topics of interest and not miss a thing. Of course, we're going to miss seeing colleagues face to face, but I think that'll come around again. In terms of the industry in general, what I see happening is I think the pandemic has really put a clear spotlight on our humans' ability to adapt when they need to. And hopefully that becomes a motivator to take a lot of things that we've been talking about in this conference in particular for years and years and years that remain out on the edge and bring them mainstream. So I'm excited to see that sort of evolution stimulated by the fact that we've had to force adaptation onto humans in general, but specifically our industry.
I would say the pandemic really hasn't changed our direction. It's certainly sped it up quite a bit. but even before the pandemic, we were already headed in just digital space. We've been doing remote operations for quite a number of years in the industry. As Blaine said before, DSATs was created, over 10 years ago, I guess. So we've already been thinking about it and in that space. And there are a lot of things that were in place already, right? So the pandemic just gave us the opportunity to speed things up a little bit in the same direction we've always been heading as an industry.
So Nils, you asked about what kind of stuff we are excited about, and as a guy who's like very kind of academically oriented, not part of oil company or the oil industry, really. One thing that excites me here is that the oil industry seems to be picking up on something that other fields and other companies have had a lot of success with, releasing data, releasing tools to work with the data, and letting people start make innovations on their own. So just from the time that I started working on my postdoc in 2018 to now, the situation is quite different. Now we actually have open data sets we can use, some at least, and we have open source programs to read data that we didn't have in 2018. So things have changed quite quickly, and I hope to see that change go on as well.
Yeah. My thoughts are around similar lines. As everybody is probably following these days, there's quite a bit of drive towards where we're getting our energy from, and we see a lot of uptake in the renewables, and that's really good. But at the end of the day, we still would require drilling to kind of balance the base load. And so it is really exciting, once you realize that, that you'll always have to have drilling technology. And then basically our goal becomes to make it as safe, as environmentally friendly as possible, and try to basically improve upon the technology. So, and given everything else that's happening in the data analytics and the vision world, it's an exciting field to be working in.
Well, guys, I'm really excited for you, all of you, and the conference ahead, because I mean, just the level of conversation we've had briefly here today has been amazing, and I know that coming up in the conference, we're going to see the same level of conversation and questions from the audience. So great interaction from the audience. I'm very excited about our industry. Obviously, just picking up from what you just said, Pradeep, we're going to need drilling for a long time to come, because oil and gas is the base load for global energy. Very excited about how rapidly we have adapted to technology this last year. I mean, Crispin, you just said, DSATs has been around for a while. Yes, it has, but I think maybe people have become far more aware of what we can do remotely. Now we've been forced to work remotely this last year. So maybe that's going to push and accelerate innovations within the drilling automation space. So very, very exciting. Guys, really a big thank you for everything you talked about today. It's been a really good conversation. So thank you very much, everybody, for that and joining us today. Thank you to the audience. Also, you've been great. Really good conversation with you guys and good questions and comments. So thank you very much. And finally, a big thank you to the SPE Foundation for sponsoring this SPE Live and making this all possible. So from all of us in the studio, Alex and Asha, Blaine, Crispin, Pradeep, and Erlend, all you guys, thank you very much. And we all wish you a good and safe rest of the day. Thank you.
Thank you.
Yeah, thank you.